off. You have to turn it off.
Yeah. Otherwise, you can use the screen. You sure?
It doesn't work. Okay.
Okay, it seems to work. So you are.
Okay, are we ready? One time? Okay, welcome everyone to this celebration of science. because it's done. I mean, after 2 years of intense work, this is the moment, just 15 minutes ahead, and you are a master in science, marine science. So today we will have 3 presentations, 2 about sharks and another one about lactose and food web. That sounds interesting. Everything is interesting today. And for all the presenters, remember that you have 15 minutes. 2 minutes left, I will say to let you know. And let me introduce the two brothers. I am Jason Borrell from the University of Oviedo, and we have with me to Audrey. Audrey, you are from University of Bergen. That's it. Karin from Faro, from the University of Faro, and Gonzalo Machado from the University of Oviedo. Good luck for all the people that will be presenting their work today. Enjoy. Okay? The floor is yours.
40. More than 40% of elasmobranch species are under threat in the Mediterranean Sea. This area represents a hotspot of marine diversity facing numerous anthropogenic dangers such as pollution and habitat degradation. The Adriatic Sea is not the exception. There, overfishing and bycatch are the main threats faced by them. The lack of data... Sorry.
Click on something.
No, I didn't touch it.
By the way, she didn't say her name, but it's Andrea Garcia Marin.
I will introduce myself.
Introduce yourself.
I will.
Alright, so good.
First one I checked.
Your stuff.
Can I just quickly check back in OBS?
Now,
The previous one.
just doing the same.
You want to remove the light stick?
Can we could watch on streaming, right? No, it's not streaming.
There's a lot of but there's a lot of lag. It's gonna be too confusing. This?
Yeah.
Okay. Sorry about that. Is it a, do you start?
Do I have to start again?
Yeah.
Okay. 40. More than 40% of the elasmobranch species are under threat in the Mediterranean Sea. This area represents a hotspot of marine diversity facing numerous anthropogenic dangers such as pollution and habitat degradation. and the Adriatic Sea is not exemption. There, overfishing and bycatch are the main threats faced by them. The lack of data in shark fisheries and poor management is resulting in overexploitation and population collapse due to inconsistent regulations and inadequate catch limits. Good morning, my name is Andrea García Martín, and today I am presenting my master thesis on the population biology and health of deep sea blackmouth catshark in the southern Adriatic Sea. So, accurate identification of blackmouth catshark is essential due to their morphological similarities with Galeus atlanticus, which can cause confusion in fishery statistics. Additionally, size variations are clearly influenced by geographical location. This deep sea mesopredator is essential to understand the overall ecosystem health. As an indicator species, it can reflect the impact of human activities. Despite being considered as least concern by the IUCN, Galeus melastomus is frequently found in bycatch scenarios, particularly in the Mediterranean Sea, where it is reported as abundant and common. So, formulating effective conservation measures is essential for the sustainability of the Adriatic marine ecosystems. For this research, it was hypothesized that the blackmouth catshark exhibit a non-random distribution pattern in the southern Adriatic Sea, influenced by depth and habitat type, and additionally, the population was presupposed to have a general health status ranging from moderate to high well-being. The main objective of this study is to enhance our understanding of the population dynamics, specifically focusing on determining the frequency, abundance, and spatial distribution, analyzing depth and habitat preferences, evaluating the overall health status, including trauma from fishing, and investigating the diet and reproductive potential. So, a multidisciplinary methodological approach was undertaken through the research. Through 2023, commercial vessels operating between 50 and 550 meters depth near the coast of Lore, Albania, were continuously monitored. Moreover, 26 trawlers and 14 longliners were monitored after docking at the main port of the city. When samples were collected aboard, captured individuals were released alive, while deceased specimens were retained for future laboratory examinations. It's important to note that no individuals were harmed for this study, reflecting our strong ethical considerations, and each single individual was meticulously identified using the latest identification keys. First of all, samples were transported to the laboratory for detailed examinations, including magnetic resonance imaging. We utilized a 1.5 Tesla MRI scanner with various sequences to visualize the internal anatomy and also to identify some abnormalities such as muscular or skeletal trauma. Secondly, we performed morphometric measurements following companions guidelines, and we distinguished between life stages according to their total length. To assess the nutritional status, condition factor, hepatosomatic index, and relative condition factor were calculated, and a model was applied to estimate the individual's growth. Afterwards, through autopsies, the stomach contents were analyzed to identify species and to assess feeding habits. Frequency of occurrence, numerical abundance, and the Shannon-Weiner indexes were calculated through life stages, excluding neonates due to digestion issues. And finally, pathological examinations included external inspections for injuries and internal organ assessments for lesions. Moreover, melanoma profile aggregations were analyzed histologically through liver samples, and parasitological studies were carried out in order to identify and quantify parasites. The statistical analysis employed our software, and we used it to analyze the characteristics of the population, the health status, and the dietary habits of Galeus melastomus. For normality test, we used Shapiro-Wilk test, and we used the 11 test to ensure the variance of the homogeneity of variances. If these assumptions were met, we apply parametric test, and if not, we apply non-parametric test. Moreover, a chi-square test was applied to assess the relationship between categorical variables, for example, shark age groups and parasite presence. And then we used a Spearman correlation test to assess linear relationship between continuous variables, for example, shark weight and length. So, our results. Despite being considered a common species, the abundance observed in this study, 313 individuals in one single vessel for 6 months, is much higher than the one recently reported by other authors for the entire Albania, where they reported 1,000 individuals in 2 years and 9 months, let's say. In contrary to former capture records from the four main ports in Albania, our frequency is much higher, up to 860 individuals per month per toll in May and June, which are the months with more catches. Furthermore, no individuals were caught in water shallower than 300 meters, and the number of adults was surpassed by the number of juveniles in troll fishing while they were absent in long lines. This could be due to the ontogenetic distribution that this species has, that I will explain later. Okay, so for the total length, the longest recorded measured individual measured 53.6 centimeters, and there were no statistical differences between sexes. However, we think that this population under study belongs to the Mediterranean subpopulation, as the higher total length recorded falls within the range for the Mediterranean Sea, and is clearly different from a much larger Atlantic subpopulation. Additionally, condition factor and hepatosomatic indexes were compared between life stages and sexes, and we found no statistical significant differences. But we found out an outlier of a very extreme value of 12.5 for the hepatosomatic index, and the relative condition factor was calculated, and we obtained values between 0.9 and 1, which is pretty good. But we found out some outliers, more for males than females. So for these values, all the values fit within the ranges for the species. It was fine, and the only problem was the outlier, but we analyzed the outlier with other, for example, comparing with the condition factor, and also we compared with the literature, and we found out that it was a measurement error. Then, two life stages were frequently observed at the same time in MRI and also through autopsies, and sustained reproduction and a good reproduction of the species is suggested by this information, and also because there is like a higher proportion of juveniles compared to adults. However, we found out different statistical differences between the teleost intake when comparing adults and juveniles. And this, we think that is because of the ontogenetic shift that this species has, where the adults have a deeper strata feeding behavior, so they move offshore. No major alterations were observed in the melanoma-macrophage analysis. However, 11 deceased individuals recovered from trawling nets had traumatic mandibular fracture with associated soft tissue avulsion. 10 of them presented in this image here, the A, had a scar tissue present, so we assumed that they were recovering. And then one of them had the tear of the Meckel's cartilage with soft tissue, and we can also see in this part here, part of the cartilage is still visible. So we assume that this individual got caught recently and had still not healed. These individuals were damaged because of the hook removal from the long lines. And after examining them, we found out that the stomachs were full and they had eggs under development, so it means that the species, that these individuals, were able to keep on feeding and reproducing. So this highlights the high resilience of the species to fishing pressure. Moreover, no significant statistical differences were found out in the number of parasites between sexes. However, we found Anisakis and Grillotia. Anisakis, the number of Anisakis was almost negligible, but the Grillotia was quite abundant, particularly in adults. And this could be due to the fact that the adults eat more teleosts, or also to the ability of these sharks, larger sharks, to tolerate a higher parasite load. Then we found out that long lines caught more adults, as we said, but also we found out that they caught less individuals. So this suggests long-line fishing as a more selective fishing method. Trawling between 350 and 550 meters depth found in bycatch, Galeus melastomus was found in 100% of the trawling carried out at these depths. However, when we take a look of shallower depths, the abundance of this species is lesser. So it means that it's lesser abundant at shallower depths. Some studies have already presented the impact of the fishing pressure on Galeus melastomus, while others have not. And we think that this could be due to the difference in these depths of fishing. Interestingly, 40% of the bycatch in number of individuals is made by Galeus melastomus. However, they only account for less than 4% of the biomass. So this means that the bycatch estimation should not be based solely on biomass. As a conclusion, this thesis provides the very first data on population dynamics of Galeus melastomus in the Adriatic Sea. This information is, without any doubt, highly useful when management or when applying or modifying management measures to address the fishing pressure. This study has also documented the previously non-existent information on the post-capture survival of this species to long-line fishing. And as Galeus melastomus is emerging as a key indicator species of the overall ecosystem health, but also of the effect of the anthropogenic activities on the environment, this research highlights the need for effective management while it lays the ground for future conservation and research. Thank you very much for your attention.
Thank you so much, Andrea. You were on time. Well, we have time now. I don't know, Valentin, will you say me if there is any question in the...
There's no question online.
Okay. If there is someone you can say to me, and if not, any question from the... No? Oh, yes, one question.
I was just curious because you said that you had to exclude the neonates from the diet, and I didn't understand the exact issue. I mean, you didn't have a lot of...
Okay, so the lowest, like the shortest individual, which are the neonates, measure between 7 and 8 centimeters. We had 9 also. So they have very small stomachs, and they eat very, very small prey. And they were very digestive, and they were almost unidentifiable. So that's why we had to exclude it from the pre-identification study, because we could not identify them.
Okay, thank you.
Thank you so much. Okay, so Audrey?
Yes, there is another.
Another question?
I have one more question, and very interesting. Thank you so much. I've learned a lot. Is there any difference in so if you catch the shark as bycatch, and is there a time that you need to have it like in the lab for it not to be too much like, I don't know, yeah, exactly.
Sorry, I didn't understand your question.
Okay.
You mean?
So like, is it in every condition? Can the fish be used for the MRIs and everything in every condition, or like,
No, of
it
course
has
not. They need to be in not decomposed, not very decomposed conditions, so they need to be fresh, or you can freeze them. And then
okay, so you didn't have any individuals that were really decomposed or something, or like
we had some, yeah. But if we couldn't use them for the analysis, we didn't exclude them.
Thank you so much. Audrey?
Thank you very much, and I really appreciated all the different types of methods that you used for this. That was really quite exciting to see. I was confused when you said no animals were harmed in this when you really have some autopsies and some.
Yeah, it means that we didn't kill any animals. They were like already dead when we recovered them. Of course, if they were alive, we released them back to the sea, of course.
Thank you. I like your interpretation of the mixed gestational stages as well. I think that's very nice.
Okay, thank you, Karim.
I was very interested because we've done studies on bycatch and discarding of exactly these deep water sharks and trawling and this is the first time I've seen there is evidence that they survived being thrown back into the sea because of the wounds from the thing, because we assumed that most of them, because they're being brought up from 500 or even greater depth, they would not survive swimming back down to the bottom. But this is very interesting that they do survive. The other question has to do with do you know what the depth range of this species is? What's the maximum depth?
No, the maximum depth we don't know because we have been working with the samples brought from the trawlers and the longlines, and the maximum depth that they operate is 550 meters.
But in the Adriatic, are there places where it's deeper than that?
Yeah, of course. I think it's up to 1,000 or something like that, right?
Okay, because
it's way deeper, I believe.
Yeah, so because it could be that there's a refuge, the part of the population is not being fished. That's why you catch enormous amounts of these small sharks, and they don't go, they're not go extinct, because there's this part of the population is beyond the reach of the fishing.
Yeah, I agree. Yeah, they have the chance to reproduce and the population can grow and they are not in danger, but they are being caught a lot. So it's still like a lot of fishing pressure for a species that you cannot eat or you cannot use. And when you retrieve from a single trawler like 4 or 5 cages, the ones that they use to put the fish, and they are full of sharks that they don't eat, is quite impactful, right? So that's why I decided to do my thesis on this, because it was a lot of pressure even if the species still can recover. And
So you were looking at trauma and with the MRI?
No. We were looking at the overall anatomy without opening them, because it's very different when you open them, right? The organs and everything, they are not the same. So we wanted to see the internal structure when they are not open, like how the eggs are placed and so on.
So not damage or because I was thinking, there's a difference between a shark caught with a long line and being in a trawl, being banged around for sometimes hours. They would be damaged internally. Yeah,
we were not looking at the organs damage, but we were looking at the muscular damage when they are in the trawling net. You can see in the MRI the difference in length between the muscles, and you can guess if they had some kind of, I don't know, the spine fracture or something like that. And when we looked at the ones that we did the MRI on, we didn't see any, so that's why I didn't mention it.
Okay, okay, thanks. Congrats for such a nice work. Well done. So I have just one quick question. How do you think that temporality and even death might affect your result?
Temporality?
Yeah, in terms of different seasons where you might be seeing different prey items that could be detected. No.
Yeah,
so
and not only that, also the fishing in Albania, it's very temporal. So there is some time that they fish with trolling nets and another time they fish with long lines. So of course they will affect our results. We worked with the species that were the stomach contents and so on. This kind of analysis were species that came from trolling nets, not from long line fishing. Maybe it will be different if we do the study with the ones caught with the long lines, I don't know. And regarding the temporality of the species, you mean? I think they are quite stable in the Mediterranean in general, so I think this, as they reproduce a lot, they have like some kind of variations, monthly variations, but I don't think like in a long term they will change a lot the population, I mean the structure.
Thank you. Joseph, listen, Andrea, is there any other studies about other possible anthropogenic changes or climate changes that are affecting the population, that could affect the population? Because you have been focusing more in fisheries, but what about other changes for this species?
I've read, I'm not like, I don't really know a lot about this topic because I was focusing on this, but I've read some papers in regards to microplastics on the stomachs and so on.
Did you find some or not?
They found some microplastics on the stomachs, but apparently they are mesopredators. Of course, it's going to affect the food web, right? But from what I read, nothing.
Okay, so
Second.
it's done.
Oh,
Thank you so much, Andrea.
thank you so much.
Now we have Stella. What is Stella? Hello. Stella Grau, another presentation about sharks.
Yeah. But we're in a total room. Can I have the time? Just a bit. Yeah. Just checking.
So the floor is yours.
Thank you very much. Hi, good morning everyone. My name is Stella Grau and I'll be talking about the identification and characterization of a potential shark nursery area on the island of St. Martin, the Dutch side. We'll be starting with introduction, materials and method, results, discussion and conclusions. So first of all, I think it's very important to know where are we, not just geographically, but also geopolitically and financially speaking. St. Martin is an island in the northeastern Caribbean Sea, where half of the island belongs to the Kingdom of the Netherlands, or it's a constituent country of the Kingdom of the Netherlands, but it's not actually officially part of the country of the Netherlands. And the other half belongs to France. So this leaves us in a very weird impasse, which very limited funding opportunities, because we're officially a developing country, but we don't fall under it because we are also part of the European Union. And since we're not also officially part of the Netherlands, also a lot of the European funding, we cannot really get it because we cannot meet the high scientific standards that Europe required. So that leads us to not having any baseline data for any shark research conducted on the island, even though they have a very high and healthy shark population. So this is kind of like the first work that is being done on this location. So first of all, let's talk about the threats. As we all know, sharks are facing a lot of threats. One of the biggest ones being overfishing. Sharks are being killed like nearly 100 million a year. And one of the biggest threats as well is coastal development, which leads to habitat fragmentation, which is currently in its highest at St. Martin. So it's very important that right now we identify critical or essential habitats. This is not the only threat for shark species. It is also the fact they're very specific reproductive traits, since they grow slow, mature late, and have very small reproductive outcomes. So it is very important that we identify these critical or essential habitats as, for instance, the shark nursery area. Shark nursery areas are areas where sharks are protected. They have a very high food provision, and they stay on this area since they're young of the years till they become juveniles or almost subadults. It is also important to note that shark species can have the same habitat requirements. It is known that different shark species can need the same habitat requirements for their growth and their development, and therefore this is supporting the multi-species shark nursery area. To that end, in this research what we did is we analyzed if St. Martin waters were a shark nursery area for all shark species present. We were Caribbean reef sharks, tiger sharks, and nurse sharks. So what we did is we gathered all the different criteria on the literature review that have been used to declare a shark nursery area. And then with that and the miscellaneous of data sets that we had, we saw which criteria were being met for a shark nursery area. So first of all, we have size segregation. This is a literature review that will back it up. Then we have higher number of shark juveniles present in the area. Site fidelity for extended periods of time. This and like it's a time frame of several months. We also have a skewed sex ratio with higher amount of females than males. That the area is repeatedly used across years, and that there's evidences of parturition. The data sets that we had at our disposal were very diverse. So we had empirical data, we had recorded anecdotal data, and we had not recorded anecdotal data. We will discuss this more with the methodology. So for the materials and methods, for the empirical data, we included citizen science data through observation sheets to dive centers. We included also satellite telemetry data obtained through 2 different expeditions that were conducted in 2016 and 2021 with a total of 9 tiger sharks stacked, and then the anecdotal data that will be discussed further. So first of all, let's start with the citizen science. St. Martin is known to be one of the highest dive touristing spots on the Caribbean, and that means that it has a very diverse array of dive sites. It has 27 dive sites. There are in the entire coastline. They have very different depths for different habitats like seagrass, also corals, and they have like very distances to shore, levels of protection since we have a marine park and also outside of the marine park, and different levels of maritime traffic. So we believe that this was a very heterogeneous network that will have high representativeness. It is important to note that the only shark species that you're going to see when you're diving on St. Martin is nurse sharks and Caribbean reef sharks, because tiger sharks are a little bit more shy. So we are going to use citizen science to determine the role of St. Martin waters only for nurse sharks and Caribbean reef sharks. So all dive centers were given this observation sheet. This observation sheet was done with weatherproofed paper so that they could bring on the boat with them, and they would be very fresh when they were writing down the observations. It had locations, date, time, dive duration to be able to correct by effort, the number of sharks, and then specifically by the number of sharks, by sharks, the species, the sizes by ranges, because it's a lot easier to determine if a shark is bigger than 2 meters than to like just ask how big is the shark. Mostly also when you're underwater, the certainty of the observation and the sex, and you never see more than six sharks per observation. So it is also important to mention that they had a threshold of experience. So only divers that were dive masters or with above certification were actually able to fill in this observation sheet. Then for the satellite telemetry data, we basically just used the satellite tags that were deployed in 2016 with 4 tiger sharks and 2021 with 5 tiger sharks. Anecdotal data. So it is very rare to see anecdotal data added on a scientific publication or any like scientific work. We are aware that anecdotal data on itself, it lacks robustness. Oh no. Oh well.
Don't worry.
So I stopped, right?
You have been funny until now, so.
Thank you.
It's a rest.
We'll take your water.
Yeah, that's fine. Thank you.
Take some water.
We'll make them pause for you, don't worry.
Thank you. Actually, no.
So far, everything was super clear, don't worry.
That's a problem.
Yeah. It's a connection thing, yeah. I'm not an expert, I have no idea, but it seems.
I don't sound right. I just.
Yeah, you should. No.
You were
No need.
you wearing anecdotal data.
Yeah. No, I know her. Thank you. I'll start the slides if that's okay.
Yeah.
Yay! Good job. Yay, thank you. I'm just gonna try this. Yeah. So anecdotal data. it is very rare to see this data included in any scientific publication. But it is important to note that even though anecdotal individual datasets lack robustness, we do not have any baseline data, but we do have a lot of shark research that has been conducted on the island without like a real timeline. So we believe that the combination of all this data was necessary, mostly because we also don't have any baseline, so it could give a very good, valuable insight. The anecdotal data is basically conducted through what's local ecological knowledge, through interviews to researchers and divers with a lot of experience on the area. So for instance, this is Leslie Hickerson, which is the manager of Nature Foundation and has been working with sharks for more than a decade on the island. And then also we have Tatsuo Berboetz, which is known to be one of the regional sharks experts, and luckily is a St. Martiner, so also has a lot of knowledge on the area. And we also included previous shark tagging expeditions. So the difference between anecdotal, recorded, and not recorded is that we have evidences to back it up. So like for instance, any like video footage or any like photos, something like this. So then the results and discussion. First of all, the citizen science. Let's remember that this is just for Caribbean reef sharks and nurse sharks. We obtained overall 245 shark observations, which were recorded in 14 locations out of the 25. As you can see, the number of dives per locations were very diverse, with like the dive sites that were inside of the marine park being had a lot more observations. Therefore, we had to correct by effort because we had to correct by effort. And to this end, what we did is we saw if we needed to do it by sighting per hour, so like the dive duration, or if we could do it with sighting per dive. And luckily, there was no significant differences between these two, so I made my life easier, and I decided to do it sighting per dive. So all the forward analysis on citizen science, it's per dive. So it will be species abundance per dive, life stage per dive, sex ratio per dive, and location abundance. So it is important to know as well that we had a very big differences on sample sizes between Caribbean reef sharks and nurse sharks. We had 214 observations of Caribbean reef sharks and only 31 of nurse sharks. So first of all, we decided to do an analysis on species abundance, which showed that there were significant differences between Caribbean reef sharks and nurse sharks per observation. And after this, I decided to remove the nurse sharks from this study because we just didn't have enough data with only 30 nurse sharks. If you start dividing it, for instance, by life stage, you get nowhere. So we don't really know the role that the nurse sharks, the role that St. Martin waters play for nurse sharks. When we calculated the differences between life stages for Caribbean reef sharks, it showed that there were significant differences by life stages, being the highest one juveniles when you go in depth with the analysis. So we did. That was one of the criteria. Then I also wanted to see a little bit the differences in life stages by location to know if potentially this shark nursery area role was happening throughout the entire St. Martin waters or only in a very specific location. But it showed that at least for the areas, the dive spots that we had enough data, there were all significant differences, so it could potentially be happening throughout the whole St. Martin, like through the whole coastline. Sex ratio analysis. So the sex ratio tests for Caribbean reef sharks showed that there were significant differences between the amount of females and males. However, let's go a little bit deeper into it, because as we can see, the significant differences were only present on juveniles, but not on adults. The only way to visually identify if a shark is a male or a female is the presence of claspers, which are not as predominant when they're juveniles. So perhaps the absence of it, like some males might have been identified as females just because their claspers were not as developed. So we decided that this was not a correct methodology to determine sex by being visually identified. So we removed these results also from the analysis. And we also analyzed as complementary data tiger sharks that were tagged on the waters previously, which were like around 50 tiger sharks, have been tagged since 2016. And we added this and it showed that there was significant sex ratio differences with sex ratio favorable for females. We also did a very quick shark abundance analysis just to see if the marine protected area was actually playing a role in protection, and it showed that there were significant differences in shark abundance inside and outside of the marine park, showing that the marine park is potentially playing its role in protection. The satellite telemetry data, overall we had 9 tiger sharks. One data was deficient, so we removed this one, which is the second one. It is important to note that only the 9th one was actually tagged on St. Martin waters, and it's the only one that was known to be pregnant, because it was a pregnant tiger shark expedition. This tiger shark had 658 transmissions, and it transmitted for 181 days, and it was basically on St. Martin waters. Let's take a second to look at this slide. So it was mostly detected on St. Martin French side, so it's showing us size segregation since it's an adult female and it's mostly on the French side of St. Martin and not on the Dutch side. It's also showing us site fidelity because these are very highly migratory species that stay for 6 months on a very narrow area. And it's also, since it was the latest stages of its pregnancy, kind of telling us that it probably gave birth on St. Martin waters. So a lot of things proven thanks to this female tiger shark. And then through anecdotal data, basically conducted interviews with Casey Vervets, and he has a lot of experience tagging on the French and on the Dutch side of St. Martin, and he showed that there was size segregation, that the tiger sharks are a lot bigger on the French side than on the Dutch side. Also the skew-sex ratio with higher amount of females through complementary data before mentioned, and also the evidences of parturition. So research conducted before with the remote underwater videos has shown that there is baby, young of the year neonates tiger sharks present on the area, and then also through the shark expeditions conducted when I was there and also before, we've seen always neonates, Caribbean reef sharks, and tiger sharks. It's very cute. So this is a result matrix. This is basically all the criteria that we've gathered and all the data sets that have backed up this criteria with the different species and the sizes determine the robustness of the data that we have. So higher number of juveniles, empirical data of Caribbean reef sharks, size segregation proved through empirical for Caribbean reef sharks and anecdotal for tiger sharks, size fidelity for extended periods proved with empirical for tiger sharks and with anecdotal for Caribbean reef sharks, skew-sex ratio with higher amount of females for tiger sharks with anecdotal, that the area is repeatedly used across here as far mentioned. We don't have baseline data, so we cannot know this. And evidences of parturition proof for tiger sharks and Caribbean reef sharks with different data sets. So conclusion, there's clear evidences for the first multi-species shark nursery area for Caribbean reef sharks and tiger sharks in the northeastern Caribbean Sea, showing that St. Martin waters are playing a crucial role in preserving shark populations on a regional basis. However, may I add the pitfalls also of this study, because obviously we had to remove nurse sharks from the study because we didn't have enough data. We also don't have any long-term study conducted on the island, which is kind of like the most recent shark nursery declarations are requesting this data. And also we are missing the whole eastern side of the island because we were not giving any monetary reward to the dive centers, and this area is just rougher and farther away, so they were not conducting observations there. However, we are currently in discussion with the UCN Shark Specialist Group to be able to declare that important sharks and ray area, so it's still very promising results. Thank you.
Thank you so much. So, time for one question from the audience, please.
Did you make yourself the diving sheet for the centers?
The observation sheet? Yeah, we did it because last year there was a workshop with citizen science by the UCN Shark Specialist Group, and they gave us a little bit of hints on that.
There was only one.
I know you said you had to remove the nurse sharks because of the lack of data, but did you get anecdotal data about them anyways? Like, do you have
anything? No, to be honest, like they're just the population of nurse sharks inside of St. Martin doesn't seem to be very big. Like for instance, on Seba, which is a neighboring island, on the Seba bank, there's so many nurse sharks that it has requested like hundreds of thousands of dollars for Wageningen University of Research, but it seems like they have all nurse sharks. We already have any.
Thank you.
Yeah, so first, congratulations. I think that I will mention it the other way. Despite these few pitfalls, you did this and that, so just to be more positive.
Yeah,
Great
there we
job,
go.
well done. So, and related, to the previous question, did you do some sort of validation for citizen science using some control areas, something to control for data? Because citizen science is great because you allow you to reach huge audience and a lot of data, but did you have some internal control to say, okay, somehow are represented, are showing at least what anecdotal data are telling us? Did you use this sort of comparison?
No, to be honest, what I was mostly doing is comparison through dive centers.
Okay.
Because they don't communicate with each other because like competition there, since it's like one of the highest touristic areas, it's pretty big. But they're diving on the same spots. So, and they also like through conversations as well with them. For instance, with height side fidelity, it was very interesting because the different dive centers had named the same shark differently, but it was always present on the same area, or like the fact that there's always more sharks on the cargo. It was always, like through conversations and also just with the data sheets that I was obtaining through the different dive centers, it was always like pretty.
Yeah, and the question, sorry, just quick. And the question was designed. You mentioned that it was designed by expert on what?
The observation sheet?
Yeah. Exactly.
No, so like.
Did you test it? Because normally when you develop this sort of questionnaire or observation sheet, whatever, so you first try with a small group and then you correct and you.
Yeah, well, I mean,
that's what was done somehow.
I did that kind of like on the way. So on January I arrived on the island, but I had to also have another job at the same time because we didn't have enough funding for this project. So while I was starting the other job, I started that conversation with the different dive centers, and then I was in a workshop with the Ocean Shark Specialist Group last year. Luckily, it was conducted online, and it was through for citizen science, so I got some contacts there, and I just showed them the observation sheet, and the dive centers and also some experts gave me feedback on it.
Great, thanks a lot. Well done.
Thank you. Karim?
Yes. So when I think of nursery areas for sharks in the tropics, I think of very shallow water, mangroves and inside the reef and stuff like that. But here you're focusing on deeper water. Do you think that you could have missed some nursery areas that are more inshore?
Sorry, I didn't understand the
No,
question.
I mean, you didn't look at what's happening in shallower water, inshore.
Oh, well, I mean, some of the dive spots are actually inshore. Well, like for instance, these ones are very close to the shore. I'm not sure if you can appreciate it on the map, but if you're there, it's like literally right there. And they actually had a lot of observations, but zero sharks.
Okay. Is there mangroves?
There were mangroves. They're not anymore because they've been removed.
The other thing, you talked about citizen science. What about commercial and recreational fishing? Did you do any survey? Would they have any information on?
No, I mean, I went to the fishers market and I conducted some I had some conversations with the fishermen, but they actually don't land so many sharks for the type of fisheries that they have over there. For instance, I was working on fisheries on Ceiba, which is a neighboring island, and they have like these very big cages for the Caribbean spiny lobster, so they get nurse sharks inside that, but it's not the same type of fisheries on St. Martin, so they don't really have any information. Or did you want to share it?
Okay.
Thank you very much. It was very insightful. I also have some questions about areas and things like that. So, did you include the zero abundance in your analysis?
Yeah, so like, this was like, if I went into this, it would have like definitely not been 15 minutes. So, do you mean like that it's not included here?
Well, we don't know where they don't go. So this.
It's included it's included in the analysis. And there was just one location, and you can see it on the map, but I don't know why it has like this color.
So all of those very, very shallow sites that you just showed us did have sharks in them?
No, they had observations, not sharks.
Yes, but the zero sharks don't show anywhere.
Yeah, no, I don't know why. Is this?
Okay.
but they were included.
So so you are suggesting that the MPA is working.
Yeah.
So first question, how long has the MPA been in?
The MPA has been officially in place since like the 90s.
Okay.
But I'm saying the 90s because like it's very hard to actually pinpoint a date on the declaration, because if you talk to the previous manager of the Nature Foundation, it will tell you one date. If you look online, it will tell you that it was actually 2016.
16.
That's like, it really depends on who you're asking, because it's
What does the legislation say? My question
there's
is,
not really legislation in place.
what?
There's not really legislation in place currently. It's being developed.
So, my question is, which came first? What's the chicken and egg argument here? So, did they place the protected area because that was an area that had a lot of things, including sharks in it already?
Oh, no.
Or
No. So actually, if you see the original plan that they had for the marine protected area, like 2 decades ago, it's actually like, it's very sad because they wanted to declare the whole island, like the whole coastline, a marine protected area. But it's okay. However, it's an area that is very, like, it's in a spike on coastal development. So this was actually the area chosen for absolutely no, like, scientific reasoning. It was just because it was the area that disturbed the least the people that were making the decisions.
Yeah.
Yeah, can I just ask, in these dive sites, do they chum, to attract sharks?
No. There's no chumming on St. Martin waters for more than 5 years now.
Because that might affect.
Yeah, that might affect.
Thank you, Karen. Stella, what are the implications to declare an area as a nursery, and how can this affect the diving center, the activity, the tourism activity in the area? Is there any implications that could be affecting
the dive centers?
Yeah, or
I mean, the restrictions.
I'm thinking about they willing to participate and to give you data. I mean, when you are working with citizen science,
yeah,
you need to take into account many aspects
about
the information they are giving to you, no? Or,
you mean if like they were biased because they maybe didn't want me to?
Yeah.
No, not at all. Like they were actually very implicated. Like it's hard to paint a picture, but St. Martin right now, it's just basically being like completely destroyed. There's a lot of abandoned buildings, there's a lot of runoff because of the coastal development that is completely uncontrolled, and that is also affecting the health of all the coral systems. So actually when you go to a dive center saying, hey, I want to protect something, they don't think, oh, that's going to affect me negatively. So I really don't think that has affected negatively the results of this study. Also, on like future restrictions, if that's what you mean, St. Martin is not very well known for having restrictions or enforcement, so I don't think they even like thought of that, because I didn't either. If we go very far, like the declaration of the important sharks and ray area, maybe we start doing something, but mostly what it will bring, or how I sold it, is kind of like just more money, because it would be the first shark nursery area on the northeastern Caribbean, and it's already a very high density touristic dive spot. So
no, I was asking just because in my experience, it depends on the type of stakeholder you are contacting, using information or other. I mean, it's different when you are talking with the fishermen than we are talking with the citizens.
Yeah.
All the citizens are worried about conservation, the fishermen are worried about their activity and conservation, I mean. Some of them also.
Yeah, no, I really don't think it would have affected, because unless also, it was very hard to obtain this data. You have to go after these people, they don't give it to you. So I also made friends with them, and it was most of the things that I've learned have been actually also through conversations. And I really don't think they have that point of view, at least not so far.
Okay, it's done.
Is that?
Thank you so much. What is Nadim? Yeah. Okay. Nadim Plata.
Yeah, I really don't want to do that.
Thank you, Tim. Okay, the floor is yours.
Hello everyone, my name is Nadine Plata-Klingler and I'm going to talk to you about my master thesis titled Modeling the Pleistocene Pelagic Throughput of the Eastern Mediterranean, which I've been conducting under the supervision of Constantina Ghiadi and Marta Cohen. The aim of this thesis was to develop a new approach to model ancient marine food webs that uses local paleontological and hallucinographic data. Why did we do this? First of all, because we wanted to understand past ecosystem, as it can give us very valuable insight, for example, about climate change, and in general, because developing a new method is of great educational and scientific value. So let's start by explaining what is modeling. Modeling is the representation of reality in a simple but plausible way that will help us study our complex reality. So the idea is to paint a picture. In our case, of a food web that will look sort of like this. How do we do this? Well, it depends on the type of food web model. So we can either work from a qualitative or a quantitative perspective. So we can either work with presence, absence, or abundance biomass information. We wanted to work from the second perspective, so we used EcoPath with EcoSim, which is the software mostly used for this task that works under the presumption that ecosystems are mass balanced. With this abundance biomass information, among other parameters, is how we will characterize the different groups that form part of our food web, what we call our functional groups. However, to truly paint the picture completely of our food web, we also need to find the interactions between these groups. And this is not so easy, as the title hinted out, because we're working with the past, we're working on a paleontological context. So we do not see directly the interactions between species, and that's a challenge, it's a limitation, and that's the reason why there's so very few examples of modeling the past, the modern past food webs. But in general, we have also great advantages with working with the past. First of all, we were not there, so we don't have to paint ourselves in the picture. And it's great if we want to distinguish natural from anthropogenic impact. In general, the past is a great indicator of our present and the future because we can find many situations analog to situations we want to study in the past. But going back to these interactions that I just mentioned, in the field of paleontology, there's two ways of inferring them. We can either infer them manually, that means working with gut contents, predation marks, or assuming the same diet as the closest living relative, or we can use probabilistic inference, so with probability. The probabilistic inference has been the one mostly executed in the few examples that we have. However, we're working with the manual inference, and to explain why we work with the manual inference and we consider the only appropriate and suitable way, I have to explain our time frame, which is the Pleistocene. The Pleistocene, but specifically these three marine isotope stages, MIS 20, 19, and 18, which are two glacial and one interglacial period, all of them with their own duration and their own characteristics of sea surface temperature, as you can see here in the slide. But why do we study these? They belong to something called the early middle Pleistocene transition, and that means it is a moment in time where there was a shift in climate. There's a critical shift in climate where the changes between glacial and interglacial would happen less often, but it would be stronger. So it's interesting to study. Additionally, the degree of change that we see here in the sea surface temperature between glacial and interglacial periods is what we expect by the end of the century if we continue under a high emission scenario. And last but not least, MIS 19 has been said to be an exceptional analog to the Holocene, so the period we are right now, but the Pleistocene was 2.5 to 0.01 billion years ago, which might sound like a lot, but if we put it into the whole context of the history of the Earth, it is what a geologist would call yesterday. So if we work with the manual inference, with the closest living relative, it's not unreasonable, it's actually good, because the closest living relative is actually close. And to fully convince you that this is the only appropriate way, all of the species I used, except one, they still exist today. So if we assume that they had the same diet back then that they have now, it's not unreasonable. So let's add our manual inference here and our little temporal context, and let's move on to methodology. One thing I have not mentioned before is that this quantitative perspective of modeling the past is something completely new, and this is the sole reason why this presentation, my manuscript, has so much methodological focus, because it has a methodological focus in a sense that we're creating a new methodology. In particular, what we wanted to test is how to treat our data. Treat our data based on these two assumptions. Either fish are driven by their preferred depth or their preferred temperature, and this would create models A and models B. It might seem very easy, very logical, but at the preferred depth, there's a specific temperature, just to a little reminder, because it will make sense in a little bit. But for now, I have 3 MIS and two assumptions, so in total I created 6 models. Now let's really talk about methodology. First of all, we had some observational data, which is the center, the focal point, how we would start building our models, and this comes in handy to explain our spatial context, which is the Eastern Mediterranean. The Eastern Mediterranean, but specifically this little island in Greece, Lardos, an excellent location for paleontological sampling, where there was a sampling conducted, and otoliths and shell assemblages were sampled, which will be our observational data. Otoliths, by the way, are fish inner ear structure. With these, we would characterize our fish functional groups and our bivalves. But to work with Ecopath, we need a little bit more. We have to get all of this information. First of all, we need a diet matrix, and then out of these 4 parameters that are here in the slide, we need to input 3, and the software will give us the 4th one. In general, you input the first 3 and you let the ecotrophic efficiency be estimated by the software, as it is something you cannot measure in the field directly. But there are exceptions. So let's see how I obtained all of this information. First of all, the biomass. As I said before, we have observational data, and this will characterize our fish functional groups and our bivalves. But the food web has many other functional groups that we need to consider. If not, we would have significant errors, imbalances in our food web. And we did not have them in the sampling because they did not leave fossil remains. So for those groups, we used literature, they existed back then, and we used literature to construct ratios to obtain reasonable values of biomass we could use, and we also used this literature to correct our ratios. The next parameter is the production over the biomass, which is actually the mortality, and the mortality can be divided in natural mortality and fishing mortality. However, we're working with the Pleistocene, we were not there, no fishing, so this equation is simplified very, very easily. And we use this standard equation in the field to obtain the mortality of the fish, of our fish functional groups. And in this equation, we have this little parameter t there, which is the temperature, and there is where we're going to make the distinction between models A and models B. For the rest of the functional groups, we used literature, we searched for values that they had in other papers, but all of these other papers, of course, they were using their own temperature, so we just had to correct it for our temperatures, and we have these equations to do so. The exception was for the predators, because we worked with the assumption that in the Pleistocene, under no fishing pressure, they would live longer. They are at the top of the food chain, so they would live longer. And this information is how we would calculate the PB, because the life expectancy is actually the inverse of the parameter we're looking for. The next parameter we wanted to look for is the consumption over biomass, where we have, again, some standard equations in the field to obtain this consumption over biomass for our fish functional groups, where we again have this parameter t, which would make the distinction between models A and models B. And for the rest of functional groups, we used the correction for temperature that I just mentioned before. The next one is the ecotrophic efficiency. We usually let that one be estimated by Ecopath, because, as I just mentioned before, the only exception was for our phytoplankton functional groups, because we had no information about biomass whatsoever, so we input a reasonable value, and then we get that estimate from the software. We also needed a diet matrix to construct a diet matrix based on these two assumptions. One I already mentioned before. We constructed the diet matrix assuming that they had the same diet as their closest living relative, and we also assumed that the diet would stay the same throughout the 3 MIS. The next step was to obtain mass balance models, that means adjusting some diets, changing some values, etc. And what we observe in general is that models A were easier to mass balance than models B. That does not mean they're better, but what it does mean is that we had some outliers in the otoliths, so otoliths that were either very big or very small, and so very big fish or very small fish for what the species is. And even with models A, with just slight adjustments, they were able to be best balanced. So it was easier for me, at least. Then this is how my models actually look like. This is MIS 19A. If you're curious, this is the parameters I just talked about, and the diet matrix, and the visual representation. Let's move on to our results. We evaluated our results through some indicators and some estimates. I have already mentioned an estimate, which is the phytoplankton biomass, which is the graph here on the left. And what we observed is that there was higher phytoplankton biomass in the interglacial and MIS 19 in the warmer period. This result is actually validated by some other results my supervisors are currently working on about total organic carbon. We had a lot of indicators, and I present to you one here, which is the total system through output. The total system through output is the total energy that flows for an ecosystem, and it comes in handy to explain one of our results. One of our observations is that we have very similar results, similar trends between models A and B. The structure is very similar, as you can see here. We also had a few maturity indicators. I present to you here too, and it's important to assess maturity because mature ecosystems is our goal, of course. They are stable, they're sustainable, they're resilient. They have a lot of properties we really are looking for. And what they're trying to say here, the total biomass over the total throughput and the total primary production over total biomass, is that MIS 19, the warmer period, the interglacial, is actually the most immature system out of the three. And it's important because if we're continuing our trend of warming, well, if we continue, it means more immature systems. We also wanted to compare our models with modern models, which is not always possible, because as I said, we're working with paleontology, we have a paleontological sampling. So not all of the fossils are, of course, preserved, so it's not always possible. We cannot compare absolute values, because they are not comparable, but we can compare ratios. So this is what I present to you here in the slide. At the first glance, what we see is that, we have higher primary production. And in general, the rest of the results make a lot of sense, because the purple one, which is the top one there, is actually of Corrales, so Israel, and they work with Reception invasion. So the area and all of those characteristics make totally sense that they have higher primary production. And the counterpart is, for example, the pink one, which is Keramidas. They work with the whole Aegean, and of course they would have lower values of primary production. In general, what we see is that our results are not so far off from the modern ones. Good, that means we were not so far off. And so also a conclusion we can say is that maybe this trend of warming might have already begun, and we have to be a bit concerned because, for starters, our models model thousands of years, and this warming, this increase of temperature is expected by the end of the century, and with its consequences. I just wanted to finish the presentation with some take-home messages. The first of all is this work lays a foundation on how to model past webs with Copepod, so quantitative model of the past. In general, the results between models A and B are consistent, which doesn't mean one is better than the other. What we also want to say with this is that if there is not information available, for example, about preferred depth, using the preferred temperature is reasonable. And last but not least, MIS 19, the interglacial, the warmer period, is depicted as the most immature system of our indicator. Thank you very much for your attention.
Thank you so much for your presentation. Question from the audience? The website, is there a... No. No? So, I'll
You'll have to stop me because I have a lot of questions. I was really excited to read the abstract and also to see, first of all, I loved your presentation, engagement, and your sense of humor in describing things. I really appreciate it. Congratulations in being able to do that while you're nervous.
Yes.
So I was really excited because you were going to do food webs with otoliths, and yes. I work on stable isotopes in otoliths and metabolic rate, and you did none of that. So I was like, Rrr. But anyway, so is this correct? You reconstructed a community of pelagic fish based on species identification, which are based on the otolith shapes.
Yes.
Okay, and your main assumption is that because those species or close relatives are extant, right? And we know their diet now,
Yes.
and we know their feeding trophic interactions, we can assume they have the same diet.
Yes, that's how we would build the models.
But there is a body of literature on changes in diet because of climate change. So what we see now is that within 20 years, within several decades, fish change their diets.
Yeah.
So how good is your assumption?
How good is my assumption? Well, for starters, we obtained what we were looking for, which is mass balance models, which is our goal. And if it works that way, first of all, we were able to construct a model, which is what our primary goal. And I think in general, even with those changes, it's better. What we were saying is that it's better with the because we're working with the past. We have limited information. Use the limited information we have. Go with it, than just blindly go around. You know, I guess.
Okay.
I don't think you're very convinced.
That's fair enough. No, I'm asking you your interpretation, so
Yeah.
Okay.
Jordan?
Yeah.
Okay, Karim? Yes, well, I never thought I would see ecopath being applied in this way. Of course, there are hundreds of ecopath models applied to now, and it's difficult enough to apply them now because often there's not enough data and we have to find parameters from somewhere else and say, okay, well, the diet of this species here is similar to, we'll use the diet from somewhere else. So you use otoliths from what, the paleontological sites, or
Yes,
based on human, assuming that that was people were catching them and consuming them, right?
No, they are. There's a site in Lardos, which is a great paleontological site because of tectonical shifts. They were underwater, but now they're on land, so it's perfect for sampling.
Okay.
And it belongs to these 3 MIS. Yeah, so the otoliths belong to the past, and no consumption, no humans involved there.
Okay,
just collecting them.
Okay, but in your model, it looked like you had very relative compared to usual ecopath models where you have sometimes dozens of trophic groups. You had 6 or 7 or 8, not very many.
We had 17 functional groups.
17? Oh.
We had a lot of fish functional groups, but because we don't have that much veridic information, we call the otolith information it's more reliable than the rest that we just constructed a ratio on, because it's firstly based on these pelagic groups. But if we divide all of these functional groups, we could have divided the benthos into everything, or the zooplankton into jellyfish and a lot of things. But because we have this limitation that we don't really know that much, it's preferable to just group them to have less errors, and that's why we have only 17 functional groups. I can show you. Here are the functional groups if you want to see. But our main focus was the pelagic. So that's why we have this much distinction in the pelagic groups, and then the rest to just construct that it's not unreasonable, so that we don't have imbalances in the food web.
Mm-hmm. Okay. The other question I had, you use Pauli's empirical model for natural mortality, but there's an empirical model for the Mediterranean. Why did you not use that one to be more appropriate, I think?
I followed the instructions. I think
no, it's by Jabali et al. It's based just on Mediterranean species, which I think is more appropriate. And these empirical models give very different values for.
I will take note of that too, because we're gonna keep working on that. We have to, one of the things we want to do is either change diets, and I worked before, these temperatures that I worked with were. They gave them to me a bit late, so I worked with so I have more than 6 models in reality, but they just had a low temperature. I'm just presenting 6. But yeah, we wanted to take all the notes as possible to make a lot of changes to see how really to work with this. So thank you very much for your comment.
Okay, so first of all, congrats. I agree with Audrey. I mean, to to make a catchy talk like you did is not easy, even particularly with this topic with ton of information. So well done. I think all we agree that it was so catchy that we cannot blink even. So well done. I really appreciate that. So I think it's a challenge. I mean, it's quite challenging what you are trying to do. I mean, apply this current model, really complicated models applied to nowadays data with so many variables. So it's not easy. So somehow you need courage to do that. Well done. So I'm more concerned about, okay, so you test different models, but have you tested different scenarios where you, by removing some of your variables that you're using, how that affect how unrealistic your model became if you take out some of these key, or how it's affected by extracting some of the groups? Because if your modeling is really clear, or somehow with all the assumptions that you, of course, you mentioned, but to detect which of these variables that you're assuming is the most important one, or the one that affect more your system. You know what I'm trying to say?
I guess you meaning the groups, if we remove some of the groups.
Yeah.
We have not tested that because we are already working with very general groups like predators as a big group, not dividing them.
But to see the tendency of the change, so
we could do
some.
that, but I think so the problem would be obtain mass balance models. I had a lot of struggle to obtain mass balance models at starters because we had some other functional groups that we had to remove to get mass balance models. We had foraminifer, so it was better to just get the general idea. I think we did not consider removing them because we read so much literature that if you remove the food like predators or just the zooplankton.
What I'm asking is if you remove some key part, or you might expect which tendency will go to see if your model is really reflecting that or not. That's what of course you don't need to remove, but just to see if it's affected in the way that you might expect. That's what I'm trying to say.
How to test the robustness of your model.
That's what I'm trying to say.
Okay.
Because you may expect, of course, if you remove certain items, your model should give you towards a certain direction. If you remove all and that it's telling you that somehow
yes.
I mean, you have a good representation, it's a good model.
If you remove some of the group, what you get is not a mass balance model. That is a consequence, and that's what we didn't want. So that's why they are all here, and that's.
Okay.
I think that's.
I got it. Thank you. Thanks.
What extinction? No, not extinction.
No.
Not the
Not this one.
No.
Not this one.
Can you show the picture with the otoliths, I think?
You have to
Yes. I would like to see that in the presentation.
The thing is that I did not do the otolith analysis. I just showing it here just if someone is curious because the otolith identification and all the characteristics, they're part of my supervisor's work, but it was already conducted. So.
But it's part of the background because that's for me the real data. All the other thing is like, okay, let's try. But I just want to say that it's very difficult to open new doors. And possibly you are making a lot of mistakes. But it's the first attempt or the second attempt. And possibly many people will help to improve your system. It's very difficult. When you were talking, I was saying, how this girl choose that topic? Because it's very difficult. I mean, it's very difficult. To say that, and I just want to congratulate you for your presentation, and obviously this is just a start.
Yes.
Let us see how this evolves, how other specialists criticize your work, and how to improve the models, and how to test the robustness of the models, the robustness of the assumption. I mean, because you are guessing a lot, no?
We are going to test how well our models are by independent proxies. So one of them was, for example, the total organic carbon that my supervisor is working on. We're going to work with what you mentioned before, a lot of isotopes to really determine but this is just the beginning. There was no time, it was another parallel experiment that is still not completely done, so yeah. So far, the results are validating my models, so that's good. But we'll see, there's more to come, I guess.
Okay, congratulations.
Thank you very much.
Okay.
of you in the audience, and for all the people that will be online for this second session of this celebration of science. I mean, after 2 years of intense work, traveling and doing a lot of things and a lot of work, so this is the moment. 15 minutes and you are done. Okay? We will have today in this session Sarah, Florence, and Julia. Introduce yourself at the beginning of your presentation. You have 15 minutes. When 2 minutes left, I will say, just to let you know that you are on time. And I will have with me to Audrey from Bergen in the tribunal, Judy, Lars from La Sorbona, Gonzalo Machado from UNIOBI, and I, Jason Borrell from UNIOBI. So, the floor is yours, Judy.
So thank you and welcome to my thesis presentation. My name is Sarah. And so the current status of the assessment of elasmobranch states that about 1/3 of all shark and ray species are globally threatened with extinction. And the discipline of conservation genetics and molecular approaches can actually contribute information that can be used for management and conservation purposes. And this is why I studied the genetic structure and evolutionary history of 2 nearshore shark species under my supervisor, Professor Adam Stowe at Macquarie University. So my thesis is actually divided into 2 parts, and this is also how I'm going to present it today. So I worked with 2 different types of genetic data, and for the first part I worked with an already existing data set which contains genetic markers that are called single nucleate polymorphism, short SNPs, and it is on the Galapagos shark Carcharangus galapagensis. And for the second part I also got the opportunity to do some lab work and to work with a second genetic marker which is called mitochondrial haplotypes. And this part is a small-scale study on the granular shark Carcharangus taurus. So starting straight off with the Galapagos shark. The species is circumglobally distributed and is mostly associated with waters around oceanic islands, but is also capable of traveling greater distances. And the current conservation status is at least concerned, but however, the current population trend is also unknown, which just only emphasizes the need for population genetic studies. So what has been previously done, there has been studies that focused on the Pacific region, and they identified at least 2 genetically distinct Galapagos shark populations, one on the eastern side and one on the western side of the Pacific. In terms of genetic health, there is, I explained this shortly before here, there is the contemporary effective population size, and it is not the actual population size, it's more of an abstract concept, and it is basically, very simply put, an indicator for genetic health of species. So for the Pacific populations, they currently seem to be genetically healthy, however, they also found structure within the Galapagos archipelago, and this population has low sizes. So the aim for this thesis was to genetically assess the Galapagos shark populations on a global level, which also means including samples from the Atlantic Ocean, all with the goal to get information for management and conservation strategies. And we did that by assessing the global population structure, then estimating the historical and contemporary effective population size, and then we also tested theories for the directionality of population expansion and potential influences of biogeographic processes that can influence the demographic history of the species. For material methods, we start off genetic studies with sampling, particular tissue samples, and I got a sample set of 10 sample sites, which are all across the 3 major ocean basins. You can see East and West Pacific, here's some island and reefs around Australia. Then we unfortunately only get a few samples from the Indian Ocean, represented by South Africa, and Ascension Island in the middle of the Atlantic represents samples from the Atlantic Ocean. So then you further go on with DNA extraction, amplification, sequencing, and SNP calling, which is basically the generation of the data set. And since my data set already existed, I started off my work with filtering the data, and then I performed a set of genetic analysis, which can be grouped into genetic structure and diversity analysis, contemporary effective population size analysis, which I call short NE from now because it saves a lot of time, and also spatial genetic analysis and demographic history analysis. So going to the results. Did we find population genetic structure? Yes, indeed. We identified 3 clusters, which are formed here in this principal coordinate analysis. these three clusters, which you can always see, which are also supported by a mixture analysis, color coordinated, as you can see here. So we confirmed the existence of the East Pacific population or cluster, the West Pacific, so East Pacific, West Pacific, but we also identified another cluster in the Atlantic, represented by Ascension Island, which is represented in green here. What is also notable to say at this stage is that there's high genetic differentiation between the Atlantic cluster and both Pacific ones. So what these results mean is that we have 3 genetically differentiated populations of Galapagos sharks globally. So what about contemporary effective population size? So we found varying contemporary effective population size between those clusters, and they range from the lowest value 225 till the highest value 2,750. So the largest NE was found for the West Pacific, then followed by the East Pacific, and the lowest size was actually found for the Atlantic population. Did we find any trends in the historical effective population size? Well, then we also found varying patterns across the 3 clusters, which you can see in here, East, West, and the Atlantic. These are so-called stairway plot, and they basically represent, this is the time. You have to start from here actually. This is the furthest point in time, about like 800,000 years ago. This is the effective population size, and this is like just the changes in effective population size over the last 800,000 years. So an overall trend that we found is there has been population expansion in one point in time for all 3 identified clusters. And what you also can see is overall there is population expansion for the Atlantic cluster overall in this time span. And contrasting is the decline over the time span, overall decline for the East and West Pacific. What is the evolutionary relationship between those sample sites and populations? So we did phylogenetic analysis, and this population tree is the outcome of it. And you can clearly see that Ascension Island, the Atlantic population, diverges first, and then later both Pacific populations branch off, and they're all build monophyletic sister clades to each other. So how do we interpret these results or put them in a larger context? First of all, the genetic structure of the Galapagos shark is actually a common structure that are found for circumglobally distributed sharks. So previously, biogeographic barriers that have been identified are large stretches of open ocean and oceanic currents. We think the separation between the Atlantic and the West Pacific is likely the result of a thermal barrier. So in this case, this is the cold Benguela current, which is flowing northward from the Arctic. And this might restrict migration between these 2 ocean basins, and therefore also might restrict gene flow, which then results in the strong distinctiveness between population, which I already mentioned. Yes. So we also suggest to classify the Ascension Island Atlantic population as a separate management unit in terms of conservation, or even an evolutionary significant unit due to a few factors. And these are, like I mentioned, the significant genetic differentiation. But we also, the phylogenetic analysis also showed that this population followed an independent evolutionary path. We also have reduced genetic diversity compared to both Pacific populations. Low effective population size, actually one of the lowest effective population sizes for all Galapagos shark populations. Only the Galapagos archipelago subpopulation has lower estimates. And well, next to the genetic isolation, we also have quite a geographical isolation of this quite isolated island in the Atlantic. So we think that adaptation as an evolutionary significant unit which actually comes with more strict conservation measures would greatly benefit to preserve this vulnerable population due to these factors. We also proposed this hypothesis of species directionality expansion, which we thought of an east-directed species expansion, with the origin starting in the East Pacific, using Hawaii in the middle of the Pacific potentially as a stepping stone for further expansion into West Pacific and then the Atlantic. We found a gradual decrease in genetic diversity from the east to the west along the direction that we proposed, which would support this hypothesis. However, the phylogenetic tree shows quite the opposite results, which is the divergence of the Atlantic population first, and then the branching off into both Pacific lineages. So this order of lineage diversion with the Atlantic population first could be potentially explained by the closing of the Isthmus of Panama, which is here like 3 million years ago, and it is the explanation for the phylogeography of several shark species like bull sharks, but for that result to be valid, we would need to time the phylogenetic tree, which was unfortunately not the time for. Then the interpretation of other past demographic events with the historical effective population size, with the stable plots I just showed you, it proved to be quite complex. So we looked at patterns of global climatic changes like glacial and interglacial times over the time span that was displayed in plots. And actually we found no correspondence to past changes in the population size across the clusters and the climatic events. One trend, however, that you can observe is that there's considerably lower contemporary effective population size than what would you expect from the historical maximum, and that is quite a typically common pattern for species that are of conservation concern today. The demographic is still inconclusive. Further analysis are needed, like the timing of the phylogenetic tree, which is called the molecular clock, or some modeling, demographic modeling, including gene flow as well, to actually say which geographic processes and the direction of species expansion, which are responsible for that. So what can we get out of this study? We identified a third novel population of Galapagos sharks in the Atlantic, confirmed Pacific stocks. According to the effective contemporary effective population size, the Pacific stocks are currently healthy. However, the Galapagos shark population at Ascension Island is quite vulnerable and needs conservation concern. And the species phylogeography is still inconclusive, and future research is needed in that field. So from this, making a huge jump straight into the Grinnell shark, which is also a globally distributed species. It inhabits tropical to subtropical waters, and actually there has been severe population decline over the last 3 generations, and the species is globally classified as critically endangered. So in Australia, where this study took place, we have 2 genetically distinct populations, one on the east coast and one on the west coast of the continent. And this is based on the mitochondrial haplotype analysis, this type of genetic marker that I'm also working with. However, there are also unexpected catches and sightings in the Timor Sea and Aperture Sea, as you can see represented here with these orange dots. And also there has been one single individual caught in the waters of the Northern Territory of Australia, which is represented with that red star here. So the aim of this small-scale study is actually to assign this single individual that was found out of the species normal distribution race, to assign that to one of the existing populations based on mitochondrial haplotypes. So through the methods, it's actually quite similar to the genetic methods of the Galapagos shark. We also started with tissues. I did all the lab work this time, and then instead of the SNP generating, we identified the mitochondrial haplotypes. So the results show that the individual from the Northern Territory, which is labeled here in this table, has actually unique haplotype, which only exists in the West Australian population, which is haplotype E. And the East Australian population only has haplotype C, and it's very unlikely to contain several other haplotypes. So therefore we can say that the Grinnell shark, which is found in the Northern Territory, belongs to the Australian West Coast population. So this population here. And the West Coast population is actually quite larger and estimated to be more stable than the critically endangered East Coast population. The Grinnell shark is technically protected in all Australian waters, but since the species is not common in the Northern Territory, there are no specific conservation programs and measures for the species up there. Another thing is that all the capture depth of my individual, but also the other ones, are well, quite within the known depth range of the species. So between 50 and 100 meters, but they can go up to 230 meters. But however, the sea surface temperatures up in the Timor Sea are between 27 and 30 degrees, but the preferred temperatures for the species in the usual distribution range is between 17 and 24 degrees. So that find here up there was quite unexpected. So out of the study, we have the evidence that the Grenouille sharks found in the Northern Territory of Australia belong to the West Coast population. Also, the study might encourage to address conservation of this species, specifically for the Northern Territory of Australia. And it also highlights the need for future research on a study which is not thought to be common in tropical habitats. So these are my references, and thank you.
Thank you so much, Sarah. You were on time.
Perfect timing.
Perfect timing. Okay, so any question, short question from the audience? No? Okay, let's start. Gonzalo, you are the ethicist.
Yeah, so thanks a lot for such a nice presentation, well done. Of course I have tons of questions to ask because I'm really interested in your work.
Okay.
So in fact you have like 2 theses, so that's awesome.
Well,
Yeah, it's
the
like,
second was a little, because,
I don't
well, yeah.
so, but I think I'm going
nonetheless.
to ask a little bit more about the first one because you show more details about that. So I think it's great that and you acknowledge which part you did and which part you didn't do it. So I think it's good, well done. So, but the thing is, yeah, I think it's important how you got that data. So those snips, how were generated? How many snips were done?
Yeah. Sorry, I did not have time to include that.
Yeah, I know, but now I'm asking.
Yeah.
So why I'm asking this? Because depending on the data that you have generated, it's not the same to have possible lipid disequilibrium between your SNP or not. That might affect or not your demographic estimations.
Yeah.
So can you tell me a little bit briefly?
So, as I told you, with an already existing data set, which actually is comprised of.
But was genome-wide? No, I guess no. Was
genome-wide SNPs.
Okay, but was not a reduction in the representation? Was the whole genome from beginning to end?
I think so. I did not.
Okay.
I got this data, and this data.
Why I'm
from
asking you
several
this because I was interested to see if you prune, for example, for LD, liquid disequilibrium blocks, if you have 2 markers that are nearby, they might be telling you exactly the same for a demographic process.
Yeah, this is the method that I used for
you prune that.
estimation of the effective population size.
Yeah, okay.
But we did not specifically test for liquid disequilibrium. No.
Okay, but then for demographic estimation, did you take into account that LD and remove those within LD?
No, we did not in that case.
Okay.
We did several other filtering steps, including FST outliers.
Yeah, of course.
Well, I don't know if anybody can.
Yeah, that's another thing I was thinking because did you try to see if different part of the genome are telling you like local adaptation or did you?
Yeah, so we used a neutral data set for the genetic structure analysis.
Okay.
The adaptive, the outlier FSCs are outsourced, and there's potentially work that you can do with that, but we focus on a neutral data set to determine the population structure of that.
Okay, now just the last one, I promise. So it's congrats. I mean, I'm asking because it was super interesting work. So first of all, congratulate again. So did you have data on mitochondrial DNA for those from the first part?
Yes, I think we did. I don't think we did for all, because I took this project over from a previous PhD student.
Okay.
I think she did have, because she identified in some cases if it was actually the Galapagos shark or the dusky shark, which is a very close relative genetically but also morphologically. So she had some data on that, but I did not see any of the mitochondrial data.
Okay, but you have, and I guess that was important also in your classification, and you didn't detect anything strong, rare there or weird, no?
No. Like I said, the filtering progress, I can tell you more about that.
No, it's fine. We have time later during the coffee, so thanks a lot. So we need to do something? Congrats. Thank you.
Audrey?
I'm not going to ask genetic questions with, although I think I missed your sample sizes and stuff like that. I'm going to ask about management. So, based on the genetic data, the population genetics, you are recommending a separate management area for the South Atlantic.
Yeah. For
What is it currently? What's the current management?
The current management situation is, let me get up a map, that would be easier. Well, the current management situation is actually not too bad. I did not know that before I started to study. So Ascension Island is a very isolated island in the Atlantic, and it's part of the British Overseas Territory. So what they actually did recently in 2020, I think, they assigned the whole exclusive economic zone around the island actually as an NPA. So that is a great first step. It's in my thesis, sorry I did not include it here.
It's always been a separate management area.
No, it has not. It's only since 2020. So it's an NPA. It's an overall NPA. That does not mean that they have specific protection measures for the Grinnell sharks, for the Galapagos sharks. So.
You're going?
Yeah.
Okay, Lars?
Yeah, by following on this question, this shark, as you said, can cross a very long distance.
It can.
So is it useful to have an MPA just in St. Helene, or?
There's been also studies on site fidelity, which I also did not include because time, but we did spatial genetic structure within the West Pacific cluster, and it's also confirmed by other studies that there is somewhat of site fidelity, especially if island or reefs are close together, or if there's, like in the case of a seamount, sharks like to get around that area, but it's also shown that they can venture out, and that the site fidelity is probably also seasonality, but it has not been further investigated yet.
Because there might be a risk that the mother population is not on this island, but it's somewhere else.
Yeah, but this is the only sample that we got currently from the Atlantic. The distribution of the Galapagos shark is also estimated to be around here-ish. So that would be also great to know if that maybe is a separate population, or if we have also, like in the East and West Pacific, two separate populations. So this is.
So I was surprised by how scientists are organizing a network to send tissue to each other. So how does it work?
It's actually incredible. I've got this data set from several people, and I think it dates years back. So I got the data from the previous studies that I showed you. I got these samples. Then I got samples from Ascension Island. Actually, I don't know how it come to be, but they send it to us, which is very fun.
Come frozen?
Yeah, they take fin clips, basically, teeny tiny tissue bits, and then you can put it in ethanol to preserve it. And best is a fridge or a freezer, but if it's quick enough, it can sustain the flight.
Okay. Then, so for me, genetics is a new world. I don't understand how you can derive from your genetic analysis the effective population size, how it has been changing through time. So, can you explain me how it's done?
Okay, so to that. Yeah. So, like I said, it's all very abstract concepts, and the contemporary effective population size, like we talked about, there are several methods to get to it, and one of them is linkage disequilibrium, and it's basically because it's such large data sets and people did it before, it is programs where you put your samples in or your data, and it estimates it for you. And the principle of linkage disequilibrium is, in short, that there are on the chromosomes genes or alleles that are closer together, and if you have a small population, I think I don't know which way it is around, they're more likely to get inherited together than in a large population, basically. So that is the concept of it. I cannot explain you the algorithms of these programs. I use a lot.
There were temporal something or no? I mean, you have temporal data or no?
Temporal?
Temporal data, I mean.
No, it's
the
all
samples
estimations,
is-
it's all
Okay.
coalescent analysis going back in time.
From different years, or that what he said.
The data set, that's the thing about it, such a big data set, the metadata is missing sometimes, so I cannot tell you exactly. I think it's been up to 2015, like recent till 2015.
What is the unit of NE? Is it number of individuals?
No, that's what I tried to explain. It's not the consensus population size, it's not the size of individuals. It's more of an abstract concept, and it is basically the size of a population that is affected by the evolutionary consequences such as inbreeding, reduced genetic diversity, and that can be an indicator for population health.
But would you multiply it by 10, by 100, by 1 million to have the real population size?
There you can kind of switch it, but how you would get in most cases the actual population sizes by tagging capture studies. And there are estimates, but it also depends on like group or species, how much higher the actual population size, the consensus population size is in contrast to the effective population size, because the effective population size is most of the times lower than what is actually out there.
So I also when the Atlantic is also the place with the smallest volume for this space for this population, because it's a small ocean compared to the Indian Ocean. There are maybe less islands. So would that be one reason?
No, I don't think so. I don't think that is how it works.
Because there are not so many islands, not as much as in the Pacific.
Well, if like Ascension Island, or if it's like quite remote and untouched places, the population can still be healthy and high because there's no anthropogenic pressure of fishing, no specific targeting. So it's difficult to explain the difference between those two concepts, but it is not individuals.
Okay. Sure one.
Quickly, I just want quickly. Can you explain again what the effective population size is? NE.
Okay.
In words, the concept.
Okay, so the concept is that it's the size of a population that is affected by evolutionary changes, such as inbreeding and loss of genetic diversity.
That's what I thought you said.
Okay, and see, you know this is, I have the fact.
Oh, sorry.
But congratulations for your presentation. That means that everyone is interested in what you were doing, so it's good to have a lot of questions. And you are done.
Thank you.
Congrats. Okay, so we have now Florence. Welcome. Remember, you have 15 minutes. I will say 2 minutes left.
Okay, thank you. How can I pass? Can I just? Okay, thank you.
Okay, the floor is yours.
Thank you. Welcome everyone. I'm Florence Rapin, and I'm going to present my thesis about victim grazing by Calanus at the Arctic Polar Front. It has been supervised by Sonia Bazzo at UIT. So first, I will talk about Calanus in general. So it's a mesozooplankton, it's part of the mesozooplankton community, and it's based on Arctic and subarctic environment. It's an important part of the biomass, at least in the Barents Sea, and it's the link between the primary producer to the top predators, so it has really a central part. We have three different species of Calanus. We can see their different size and also their different geographical repartitions. So Glacialis and Hyperboreus are Arctic species and are more found in sea ice covered seas. And for Finmarchicus, it's an Atlantic species found mostly in ice-free seas, and it's the smallest of the three here. And now I'm talking more about the life cycle because it's really central for Calanus, since it's really dependent from the seasonality and the different variation. Within Calanus, they are following the same life cycle, except that Finmarchicus will have 1 year life cycle, and Hyperboreus can go to multi-years life cycle. And they are really dependent, as I said, of the seasonality. So in spring, they will have an intense feeding and growth period as they follow the phytoplankton and the sea ice melting. So they will develop from eggs to nuclei and to copepodids. In autumn and winter, they will go to depth and migrate to spend the winter there at stage C4, C5, depending on the species. And they will stay quiescent, so diatos, with a large early feed stock to survive the winter. So that I'm bringing here, so they are mostly herbivorous species, and they are using the current to feed. And as humans, actually, they can ingest food that will support the metabolism, and you have the lost in fecal pellet. But they also have a lipid reserve stock to survive when they can't access to the food. And it will support the basal metabolism and the production of eggs and gonads. So now I explain the common knowledge about Calanus. So the earlier study showed that they were staying in diapos at depth and surviving the winter by using the lipid reserve. However, new studies show that they had activity found it in Calanus, so by acoustics or net sampling methods, and they were also present at the surface and not only at depth, and they were using also over winter some alternative food. So my question was, at the end, what do we know about the distribution of Calanus during winter, because it's a period we don't really have a lot of information and a lot of samples. And also to see if there is any activity, and mostly feeding activity, during this winter period. Okay, so for that, we went sampling the first week of January using the research vessel and Merensen, and we went directly to up north in the Barents Sea, across the polar front. So it's a specific area where we have the Arctic water coming north and meeting the Atlantic water coming from the south. And we dig a transect across the front, so with 6 sampling stations and 1 more in the Arctic waters. So with that, we had 2 deployments that will help us to determine if there is any activities. So the first one was to deploy 1 to 2 VP2 nets until 10 meters above the seabed. And from this deployment, we took 60 individual first stations. So it was C4, C5, and female stages, the stage that we can find in winter, over the 3 species. From that, we put each of the Calanus into forced bottom chambers, you can see here. And after 24 hours of incubation, we count the fecal pellet production per individual, and it will be our proxy of feeding activities. We also add some photo identification, and by using imagery, first we determine the chromosome length to determine the different species, and after we determine also the area of the lipid sac and of the chromosome, to have the fullness, the lipid fullness of each Calanus. The second part was more to have an idea of the water column distribution and to know where we can find either Calanus or the fecal pellet over the water column for each station. So we use the VPR, so it's the video plankton recorder, and it's an underwater video camera, and from that we can directly get those pictures. We have some things in between, but we can have this picture and determine the distribution. So first, the VPR take the images, and we will have to manually sort all these pictures from infrared view program. We classify in 18 different taxa. And after that, we have a huge part of processing in MATLAB, where we can have, after from the taxa and the depth, the vertical distribution and abundance of fecal pellets and of Calanus. So now for the result and discussion part. First, it was important to know each station was either in Arctic or Atlantic water. So we can see that the southern station are mostly in the Atlantic waters, because it's only we can see here in the warmer part, it's the temperature and the salinity here, so more salty waters. And we have the station 5 and station 1 with the Arctic water on the upper layers. We don't have it here, but we have the station 8 that also consider as Arctic waters. So from that, it will also explain the population structure over this transect, and get also indicator of the winter state for Calanus. So the species we found the most was Finmarchipus within all the stations, with a small increase in the northern and Arctic station of Glacialis. So we have the Arctic station here and the northern part here. And we have really a few Hyperboreans, which makes sense since it's really an Arctic species, so we can find it up north. For the stages, there were more C4 and C5, and really few female found during this transect. If we go deeper and looking closer into the distribution into the water column, we have really a difference between the more southern station and the most northern station. Here we have a Calanus distribution, and here we have the fecal pellet distribution. So for the southern station, they were all spread over the water column, when we can find them more at depth for the northern station. So we can also have the question about the possible activity in the southern station, because we were supposed to find them more at depth, or at least expected to find them at depth. And we have also the question for the northern one, if they were more trapped by inside the Atlantic waters. From the fecal pellet, we have really a local version of fecal pellet found, which is normal because winter is not a big biological activity period. But we can all still see that we have some at the surface and spread along the water column, so no only at the bottom, sinking at the bottom. From that, we confirm that we have production of fecal pellets over the whole station from the grazing experiment. So over the whole station, we have approximately 20% of Calanus producing fecal pellets. However, it's a low production of fecal pellet because it's really low average, and we go from 1 to 3 or 0 to 3 production of fecal pellets. So that means they are still feeding, but in really low proportion. And if we look closer, because we wanted to see if there is any one specific species that we're feeding, or at one stage, and actually we found that approximately all of them could produce fecal pellet depending on the species and stages, and over the whole station. So it's a consistent production of fecal pellet. and we wanted to combine that also with the lipid stock, because we were supposing if we found them at the surface, maybe they have lower lipid reserve and maybe they need to feed to survive over winter. But actually they were pretty full, all of them in lipids. And we had also different strategy and plasticity in feeding. For example, if we look at Finmarchicus female, we have a production of fecal pellets. For those produce fecal pellets, they have higher lipid contents compared to those that are not producing fecal pellets. And for Glacialis female, it's totally the reverse situation. So also that's true. This result that even with low lipid sac, so even if they were possibly in diapause, they were still allowed, they had the possibility to feed and produce fecal pellets. So the overall of the study is that there is a feeding plasticity in a low level but still present, and certain activity during winter. So we found that in the consistent production of fecal pellet, that could be at depths, but also one over the water column, and also for Calanus with load and fill lipid sac. For the vertical distribution, it was unexpected also to find them spread over the whole water column in the southern station. And we can have question also about the mesodiapause or a certain activity. And we have the polar impact that show an impact about the population structure, but actually no change about the fecal pellet production. I went super fast, so if you have questions.
Yes, because I was saying.
Yes. So,
Okay, thank you, Florence. Any question from the audience? Peter?
I actually have one, just out of curiosity, but the plankton machine for recording that you talked about,
yeah.
You just deploy it from the research vessel and it takes videos and like.
Okay, it just we drop it vertically from the vessel, and it just go down and go up several times. So we have approximately 7 profiles at one station, and after we will do the mean of those profiles, and it just capture every time that it see something kind of. We have a picture of it, and it's some parameters that define the difference of contrast and everything in the water, and we'll have the picture of it and the position. I mean the type. And
it's not what the focus that we can identify the species with the image?
Oh, okay. We can say that this is Calanus. In some picture, like the genus, in some picture we can see some species, but no, it's more the genus.
Okay.
Yeah, yeah.
Okay, so Lars, you start now. Okay, thank you very much for this very nice presentation. Refreshing from this heat in Nice.
Yes.
I have a few questions. First is, so what triggers your work is to assess whether there is an activity in the water column of these 3 species. You use 2 papers and you say that it's based on acoustic and net data. We believe there is activity, but what was the proposed activity?
What do you mean if...
Well, what do you mean by activity?
Oh,
and
okay.
what did this paper describe?
Yeah, activity it was more by finding them at the upper layers and not only at depths. So they found some activity and they found some Calanus at the surface, and they were asking also why we found them there.
Okay.
Yeah.
So it was because of their unusual position relative to what is expected, because we believe they are in the deep in winter.
Yeah.
Okay. Okay, thank you. How did you choose your sampling stations?
It wasn't me directly because it was a huge cruise, so it was already kind of defined, but it was mostly what we needed, like every team needed some sampling, so we have to make an agreement. And it was also, I don't know if you saw, but we were doing a lot of way back because of the weather adaptation also. So it was more about the sea ice because we couldn't go further north. So it was the maximum we could go. And so the sea ice, the weather, and what we need to sample was. Yeah.
That explains the number of stations which
yeah, I keep the number of the real cruise. That's why it's a bit mixed.
Okay, then about this imaging method you are using.
Yeah.
So you counted 6,000.
Yeah.
Why this number?
Because it was pictures, and it was only a few parts at the end that remained Calanus.
But totally, how many pictures did you get?
It was the
of Copepod.
No.
A total.
Yes,
No,
yeah. It's winter.
It's a low number.
Yeah, it's winter productivity. I think it's.
Okay.
Yeah.
I understand. Did you use any automatic recognition algorithm, or you just validated by eye?
At first, I knew that they had some automatic. I didn't do it. But at the end, we went through all the pictures to verify that, and yeah, it wasn't really. We had to change a lot of the picture. So yeah.
Okay, and maybe a last question. Your hypothesis is that the production of fecal pellet reflects the feeding activity.
Yes.
But would they produce fecal pellet if they consume their own lipid sac?
That was the question I also had. I would say, from my opinion, because we don't have that much information actually about Calanus and this mechanism, or at least I tried to find. But for me, if I read, no, it's okay. And if really they can use the lipid stock, I think it's to give energy, and I'm not sure they will produce fecal pellet at least. I think it's more reserve energy given. It's like I compare that to bear, and it's the same for bear. They are not producing fecal pellet during this period when they are in quiescent phase.
Okay, thank you. Alvin?
Very enjoyable. Thank you very much. And so you're out there in the Arctic winter. I've been there. So you don't have to worry about day-night, obviously, right? But where were you in the lunar cycle, and did you have an influence of moon?
I don't remember having this information, that's true. I don't remember if I saw the moon, but I didn't pay attention to it, to be honest. I don't remember. Yeah. But I haven't seen it, so.
And can you explain again, actually, that top graph? Because I think you had the north and south confused for me.
Yeah, it's like for all. We have the south here.
Yeah.
For all the graph actually, and the north here.
Okay.
So we have the Atlantic coming here and the Arctic weather coming from there, and we have the limit at the polar frontier.
Okay, perfect. Yeah. One more methodological question. Your images, were they stills that were taken by a stills camera, or it's the video plankton recorder which takes a video?
Yes, okay. I will explain you
the resolution.
Yes,
well, the question is about the resolution.
The resolution, I don't remember actually the resolution, but it's a video, and after you will pick the images from that, from what I yeah.
I had another question a bit on the moon thing. So, because it's always night, so do you take always the same specific hour to do the...
No. It was depending when we were arriving to the station actually, and it wasn't the same time. We had different days. It wasn't per days. If we look here, like it was I don't know, but station 1, 3, 4. It was kind of regularly the same day per day, but after it was like maybe 2 days after. Yeah.
Yeah, so thanks for such a nice work. So I really enjoyed, and you explain us really well, so I'm not an expert in that. So, and I have the feeling that I really understood what you did, so Great job, well done. So I was, I have some questions about the environmental conditions because before that, do you have a match because you, correct me if I'm wrong, but you took some pictures or video and extract picture out of that, but also you collect some samples from that. Did you have a match between these two?
I don't have a direct match between the two because
at least some sort of correlation between the data that you are recording and
it wasn't exactly at the same time first, and the one that we were collected are totally different from, not totally different because it was the same place, but they were like distinct really analysis, so I don't know how I could compare them together.
Okay, and what about the timing and environmental conditions in general? So could change from one year to the other. What do you expect? What different conditions, different parameters that you might take into consideration?
I think it was the face of the polar front because it would change between the years.
Yeah.
So we'll have a different temperature and different salinity, all the physical parameters. And after, I don't know, I think it would be, just the physical parameter that would change, but I think it would keep, at least for the migration, it would stay like that over the years.
Excellent, great.
Florence, just two quick questions. The first one is, then the fecal activity and the lipids contents for you are not collected. I mean, correct me if I'm wrong, but...
Yeah. No, for me it's not.
No, your data say no.
Yeah.
And what is the alternative then? The alternative hypothesis for that?
They are linked. That they are linked. I don't know.
No, I don't know.
Okay.
They are not connected, so...
Yeah.
Oh, and another thing is just a very global question, and it is that if you can make comments about the relevance of this research for the on this particular species for what we are facing for the Korean. I mean, why is this research important? What is saying to us, and what we should do?
I think
basing or taking as a basis your work.
I think it's important because it was first a location and a time that were not really sampled, and we don't have a lot of information about it, so it gives more information. Also, it's the migration, variation and everything. It's important because if we don't have the information during winter, it will also gain more information during summer because we have a lot of study during summer. So it's the general mechanism, and if we know how it really works, we know how it will really change in the future also. So yeah, I think it's relevant like that.
Yeah, but there are other temporal samplings to compare.
We have mostly the sampling in March and after June, July. Yeah, but in January I had like problem to find some paper and information. Most of the time the winter they consider that March, all the other papers. So yeah.
Okay, thank you so much. You're done. You should push me because. Alright. Okay, so now we have Julia.
Break the line.
No, we continue. Okay, so the floor is yours.
Thank you. So good morning, everyone. Thank you so much for being here. I'm Juliet Derry, and I will present my research that is about assessing microplastic ingestion in planktonic larvae, specifically in fish and decapod larvae, in two different ecosystems in the south of Portugal, so a lagoon and one in a estuary. And my supervisor was Joana Cruz, and we carried out this work at University of Algarve in Portugal. In the past century, plastic production increased exponentially, and of the plastic used, only 9% get recycled. The rest ends up in landfill and eventually reach the ocean. In the ocean, plastic debris accumulate, especially in coastal areas and in the main oceanic gyres. And in coastal areas, since they're also very productive areas, they're rich in zooplankton, among which we find merplanktonic larvae, which are larvae of organisms that spend only part of their life in the zooplankton and then grow up and become nectonic or benthic organisms. When plastic enters the water, it can undergo degradation and form smaller particles that are called microplastics. Microplastic range from 1 micrometer to 5 millimeters, and it can be either primary microplastics, so already introduced of that dimension, or secondary microplastics, so result of the breaking down of bigger pieces. These can be ingested by zooplankton and directly cause toxicity. And also, zooplankton can be eaten by bigger organisms and therefore be an entry point for these plastic particles inside the food web and eventually end up in our plates. So with this study, we thought it was very relevant to analyze whether fish and decapod larvae are ingested microplastics in the southern Portugal coast. And if there are differences in the microplastic ingested among taxa, so between fish and decapod larvae, and between locations, so between Guadiana River and Ria Formosa. And also we wanted to characterize the microplastics that were ingested. So we sampled in 2 different locations, Ria Formosa and Guadiana River. We sampled once a month, and always in the first week of the month and 2 hours before the high tide. We sampled using a zooplankton net with a 200 micrometer mesh size for 5 minutes with a horizontal surface thaw. And from the sample that we collected, we retrieved decapod and fish larvae. These were identified to the lowest taxonomic level possible, and then we measured them using ImageJ. These were then divided depending on their length. So for decapods, we measure the carapace length. For fishes, we measure the total length. And depending on these, we either digested them alone or in batches using 30% of hydrogen peroxide, and we put them in the oven for 48 hours. After the liquid was filtered, and we used glass microfiber filters for this filtration. And during the process, we found out that the filters, even newly taken from the package, had some microplastics already on them. So we added an ulterior step, and we checked them first under the stereo microscope to remove eventual particles that were present. Then we dried the filters in the oven for 28 hours, and this allowed us then to look at them under the stereo microscope, mark the microplastics that were present, and characterize the microplastics based on shape, color, and polymer type. So we measure them using ImageJ, and then we analyze them through the microsphere, which is a machine that gives us transmitting spectra. We compare the spectra for the particle to a database of spectra for known polymers. We calculate then the encounter rate that allowed us to compare our study to other study, and we did this by dividing the total number of ingested particle over the total number of organisms that ingested them times 100. And our data was not parametric, so we always use non-parametric tests for the analysis. So as we can see here for the encounter rate, we have Ria Formosa RF and Guadiana River GR, and there was not a significant difference between the two locations. And fish larvae always exhibited higher values for encounter rate, but this was also not significant. We then try to look at the specific taxa, and we've seen that many taxa did not show ingestion of microplastics, so many didn't ingest any. And then we try to characterize them based on shape. So we have 3 types of shapes: fibers, lines, and fragments. Fibers are more flexible with fringe margins and elongated. Line were elongated particles that were harder with smooth edges, and fragments were particles that were visibly broken down from bigger plastic debris. We've seen that fibers were more abundant than the other two in both locations, and that lines were less abundant in fish than in decapod larvae, and in Guadiana River there were no lines ingested for fishes. Regarding the size of the particles that we found, so Rio Formosa showed a more homogeneous size distribution, while Guadiana River, for Guadiana River, almost 60% of the particles were smaller than 200 micrometers. So in general, we had smaller particles in Guadiana River. And relating the size of the particles to the shape, we see that the fibers and lines are both significantly more, significantly bigger than fragments. And we also tried to look, because it was very interesting to see if there was a correlation between the size of the organisms and the size of the plastic particle that they ingested, and also the size of the organisms and the number of plastic particle that they ingested, but we found no correlation. And when we looked at the color, we mainly found transparent particles and blue particles. And for polymer type, we mainly had rayon and PET, and we have here the spectra resulting from the tear. So we found no significant difference in the encounter rate between the two locations. And this was surprising because Rio Formosa is an enclosed basin that is formed by 5 barrier islands and some inlets, 5 inlets. And Guadiana River is Guadiana River estuary is exposed to a lot of freshwater input because of course it's an estuary, and a lot of exchange with the sea. While our entry point, our sampling point for Rio Formosa was quite far away from the inlet, so even if there is a mesotidal regime, the water renewal was less prominent. So we were expecting more accumulation of plastic particles in Rio Formosa than Guadiana River. And when we look at the encounter rate for fish larvae, we compared this study to other studies. And we can see that lower values were found in studies carried out in England, while way higher values were found in studies carried out in China. But it's very complex to compare these studies without knowing the baseline of particles present in the water, because we don't know if this is due to the fact that more or less particles are present. So this should be taken into account. And for decapod larvae, we saw that some of the taxa did not show to have ingested microplastics. But when we looked at the numbers of the samples that we analyzed for these taxa, these were less abundant. So probably the fact that we didn't find microplastic is due to the small sample size. For the shape, we didn't find any bead. Beads are very small plastic particles that are usually introduced as such, and they're not broken down from bigger plastic debris, but they're very common in wastewater treatment plants, and they're also found in other studies. So it was surprising not finding them here, and this could be rather due to problems in detecting them, due to their size, than to actual absence because they're not present in the water or they were not ingested. We found that the major part of our particles were fibers, and this could be because they're less dense, so they stay more in suspension in the water column, and this means that they're more bioavailable, so they can be eaten more. Also, like these organisms eat chain diatoms, and therefore they could mistake fibers for their prey. And we found studies that analyze the removal rate of plastic particles from the intestine, and we've seen that fibers get more entangled in the intestine, so they get removed more slowly, and therefore it could be for accumulation of the particles in the intestine at the moment of catching the larvae. When we think about fiber, we also have to take into account that the number of these fibers decreases when increases distance from the coast, And this is important when comparing to other studies because the location at which the samples were taken can affect this. And we've seen that lines were less abundant in fish larvae than decapod larvae. Lines are harder particles, and juvenile fish are able to chew softer particles and distinguish them from harder particles and speak those particles. So if this is true for fish larvae as well, then it could be due to this. And it's very important to determine which kind of shapes were ingested for exposure studies, because most of the exposure studies don't represent fibers and fragments, but they use mainly beads. But these are not representative of what's found in the water, so it's important to understand what larvae are actually ingested in natural environments. And for the sizes, we found smaller particles in Guadiana River, and this is surprising because Guadiana River is a more hydrodynamic environment, so we were expecting resuspension of bigger particles and therefore them to be more available to ingestion. And also, Guadiana River the estuary receives a lot of fresh water from land, and estuaries are one of the main entry point of plastic particles in the water, in the sea, so we were expecting new particles. And actually smaller particles usually are those that are older, so it was surprising to see this difference. We found mainly transparent and blue particles. This could be because bright particles are more detectable, so they're easier to distinguish than from natural prey. But also we must take into account that when these particles enter the water, they're covered by biofilm, and therefore this would be harder to detect. Also, we used a digestion method that uses H2O2, and H2O2 has been shown to discolor some plastic polymers, especially rayon, and rayon was our most abundant polymer. So when looking at the percentage of transparent particle, we have to take into account that discoloration could have happened. And finally, a study by Steele affirmed that actually there is no discrimination based on color for larvae, so this could be subjected to further investigation. Regarding the particles, the polymers, we found rayon and PET. Rayon is mainly found in textile fabrics, so it could be due to proximity to wastewater treatment plants from washing machines. And PET is used a lot for ropes and sails in boats, and this is an area that has a lot of recreational and fishing boats. So to wrap up, in conclusion, we can say that both fish and decapod larvae ingested microplastics in the study in both locations, and the encounter rate ranged between 6% to 12%, which might seem like a very low number, but actually these are just newborn, so they started feeding since like very little time. We found mainly transparent particles, and the most common were fibers, and rayon was the most common polymer type. And lastly, the microplastic that were ingested ranged between 10 to almost 4,000 micrometers, and smaller particles were found to be ingested in Guadiana River compared to Rio Formosa. Thank you.
Thank you so much, Julia, for your presentation. Questions from the audience about microplastic? We have two? Okay, show one.
Okay, thank you for the presentation, it was really nice. Would you find predominantly decapod larvae, or would you, decapods or?
Decapods.
And would you find any other as well? Or?
Yeah, we found polychaete, we found, many others. Sea urchin, but like, decapods are more abundant, fish larvae are less likely to find, so there were actually smaller sample sizes.
Okay.
That's why also we use encounter rate, because it was a way to to compare between samples that were not the same size.
Okay.
Thank you for the presentation. I don't know if you said it, but can they still excrete the microplastics,
Yeah.
or once it's inside forever?
No, it's been shown that actually the microplastic doesn't translocate to other tissues. So in larvae, they're small organisms. They stay in the gut. They don't go to other tissue, and then they're excreted. And that's why we hypothesize that the fact that there are more fibers, it also could be due to the fact that they're excreted more slowly because they get entangled in the intestine, and therefore beads are round shaped. They pass faster through the intestine. They get removed, while fibers this could take longer.
So do you know the the feeding rate of the different larvae? Just how much they ingest per meal, you mean, or?
No, it's very hard to say because these are very low numbers. You take the larvae and you look at the microplastics, and the values are very low. So it's 1 maybe in 30 larvae, and it's hard to do for you have to carry a study in the lab to know how much you're feeding and the conditions and the season as well. But doing experiment on larvae in the lab is still very, very, very complex.
Thank you. Okay, no?
Yeah. So thanks a lot for such a nice work. So I really enjoyed. It was nice. I think you explained quite well what you did. So I have one question. How that, because I think one of the main differences that you are finding is different localities. So it's providing the main difference somehow. No, or one of the main differences. I'm surprised that you didn't take water samples.
Yeah.
Just to see if it's reflecting exactly the same, or somehow there's some active feeding, for example, of particular larvae that might increase certain type of microbiome, whatever. So
So the project initially didn't include this part of water collecting, and when we thought it would be actually important to include it, this is a very, very slow process because you have to digest them for 48 hours and dry the filter for 24. So it's such a hard process that we didn't have time to also focus on the water, because for the water samples you have to digest the whole sample that you collected. So this takes already to digest one larvae in one beaker. It takes 2 days. So for the water it would have taken much more. And we were thinking it would be actually very nice to implement it for future publications, but we didn't have time for the thesis.
Just quickly, the last one, because you mentioned, and I think it's great that you control for contamination before going.
Yeah.
How much did you find?
Of contamination?
Yeah.
So it was
the range
for the filters, you mean?
Yeah.
So it was very strange because we have a package of filters. They were the Wattman ones, the blue ones, and the top one and the bottom ones we would find 2 or 3 particles per filter, and the middle ones sometimes they were empty. Most of the times they were empty, and sometimes you would find 1, 2 particles, but it was really layered. So the top ones were very full, and the bottom ones, and the ones in the middle no, but we had to check everything.
Yeah, definitely. And it's important that you do, because definitely you have an effect because of that, and some people even what they do at the same time that they are working, they leave some filters nearby the surface that they are working, so that's allow you to correct about the environmental microplastic that you have in your lab. That's something. So thanks a lot.
Thank you.
Great job. Okay.
Thank you, Lars.
Yes, thank you for the very nice presentation. Clear. So my question is about sampling. Use a 2x2 surface tow.
Yeah.
Why such? I was thinking the plastic was almost floating. And can you, with a 2x2, be sure that you are skimming the surface?
Sorry, can you repeat?
The WP2 is not a very good net to collect horizontally.
200 micrometers, it was the mesh size. So only.
Yeah, but I'm not talking about the mesh size, about the gabarit, the frame of the WP2.
It was 1 meter. It was 1 meter.
Yeah, but usually people use Manta net.
I don't know. This was because this experiment already actually this sampling activity already started since a long time. So it was almost 20 years of data that we had. We only used the last year because of the amount of time that took to process them. But we also keep these samples for other research in the lab, and it's important to keep consistency between the way you collect samples.
Okay, I see. I'm also surprised that you only compare your data with 2 or 3 sites, China and England.
Yeah.
But I think there are many more labs working on this question.
Actually, on fish larvae, there are not many studies. So I only compared fish larvae in those tables. It's quite a new field. Microplastics is very, very studied, but fish larvae, yeah, there are a few studies. In the thesis, there are also other values, but I put the main, like England, the 2 that were carried out in England, the 2 were carried out in China, but there are, I think, 2 or 3 more, not more, no more studies.
And why didn't you look at the intestine of? Because I'm always puzzled. Where are all those fibers or line? Are they attached to the body? Are they really in the gut?
Yeah.
Why didn't you look into it?
So I didn't mention this, but before digesting the organism, these were rinsed 3 times with ultra pure millicube water under the stereo microscope.
Okay.
So I checked every organism, I rinsed every organism, and I was sure there was nothing attached to it. Because of course that's, yeah.
Okay, thank you.
Like to ask Aldi?
I'm surprised that you found so few studies of fish larvae, because I know of more than a dozen.
Yeah?
20, 25, yes. You do
But
agree?
in the lab or in the field? Because in the lab, I know that there are many. In the lab, I know that there are many, but we didn't compare the lab studies because it didn't make sense to compare the rate with the lab. So we only tried to compare it to field studies.
Okay, very nice presentation, and I think you covered a lot of aspects, and I like a lot of the bits of the design. I'm not sure how involved you were in the design of things.
The design was my supervisor, so she already had in mind the project when I arrived, and then she never done it before, so we started to look at the protocol and figure out it's hard to work with microplastics because there is so much contamination, there is so much that you have to figure out how to do. So we kind of like checking the filters before. It came after, so we did some work and we were like, this is working, this is not working, let's go from working.
Nice. I have 2 short questions. How did you define microplastics?
Like plastic debris that are from 1 micrometers to 0 to 5 millimeters in dimensions.
Okay, and that's based on a generally accepted definition?
Yeah, so there was a study by Fries and Nash that I used to define them, also in my thesis, that they try to take because there is so much discordance in defining microplastics, and they try to get to a common agreement, and so I used their definition of microplastics to base my work on.
And one final question.
Yeah.
This is your fish larvae. I mean, you have a flatfish larvae as your
Yeah.
Okay, so if you said you had a range of sizes and things like that. So, I mean, fish larvae develop.
Yeah.
And move through a range of trophic levels.
Yeah. So.
And their digestive system changes. And how did you account for that in your encounter rates and what you might have still, when you, especially clupid larvae here, when you catch them, they tend to defecate. So it's very, very difficult without special treatment to get the samples, to get a good gut content. So how do you know you got a good gut content?
We digested the whole larvae. So we didn't digest only the gut like we do for bigger fishes. We took the whole larvae and we digested the whole larvae.
No, but what I meant is that their gut empties when you catch them, the shock of it.
Ah, okay.
When they die.
Yeah, we don't know. Like, we didn't have many of these flupates, but no, this we didn't take into account, the fact that it empties.
And the difference in and the change in
we had different so we had different larval stage, so pre-flexion, post-flexion, and we only took them, so we tried to take everything that we had in the sample, because as I said before, fish larvae are very little, so we just pulled them together, the different larval stages, but keeping them in the same taxa.
You are out? Out, you are? You're done or not?
What?
You are done or not?
Yes. Sorry. No. I don't want
to. Yes, maybe the start. The question. For the decapods, I think you make the hypothesis that what did you say? That when you're looking at different taxa, and you say that some taxa do not have no fibers or microplastic in their intestine, and you give the assumption of that there were not so many individuals in your sampling. I was wondering also if the feeding behavior of the different species might not be involved, because later on you also say that feeding behavior is important.
Yeah. So actually there were some studies that say that, for example, between decapods and fish larvae, they were discussing the feeding mechanism. So since fish larvae, they tend to be visual feeders, and when there is high concentration of abundance of prey, they just gulp everything, so they're more likely to ingest microplastics. Some other studies said that since decapods are filter feeders, they filter a greater amount of water, and therefore they're more likely to accumulate. So they were discarding. And also for decapod larvae, depending on their life stage, so zoea or megalopa, they can change their feeding mechanism, so this could also affect the amount of plastic particles.
That's something you did not raise as a hypothesis.
No, because we had to choose what to address, and it's very complex to identify, it's very complex to divide them and try to see also the feeding mechanism, the information are a bit also with other studies, it's hard to compare, so we just try to be very general since it's a kind of new study, especially in the south of Portugal. So.
Okay, thank you. Thank you, Lars. Julia, I was a little bit surprised that you did not include the temporal data. I mean, because this is what could be very interesting for me. Because in our lab we are making microplastic, and I was surprised at the beginning because you were questioning, are fish ingesting microplastic? We know that they can do it.
Yeah.
There are many papers about that. But the thing is, what about these locations? What are the implications of finding this in these locations? No, this is what is, and if there is a change of with temporal data. I mean, are we increasing the number of microplastics in the environment and in the fish, and what could be the implication of that? So if you can comment something about that, I would be very happy.
Yeah. We only had we had samples for a long time, but we only analyzed 1 year of samples.
The samples are there, but there is no data.
So the samples are there, but we chose we chose to analyze 1 year, so from March 2023 to March 2024. So we could have divided them by seasonality. We tried to see if there was a trend in seasonality, but with such few amount of data, it was very hard to do so. So we just stick to the differences in location. And of course, if we had more time, like the possibility to go ahead, we would actually want to look at all the samples that we have, because it's a good amount of samples. You could compare like 20 years ago to now, but yeah, we had to choose.
No, sometimes it's very important to have the baseline data to compare in proximal. And I have been directing classes, and I know that you have a few months and you have to do as much as you can in this month, and sometimes experiments are already planned, so I mean, no, you did not take water. This is important because it's just to see how is the environment affecting this or no, and to give more relevance to your work and to transmit that information to the public opinion.
So we tried to give a baseline of what was happening, and in an area that was not yet studied for this.
Yeah, because there was no previous data in the Guadiana River.
No, for microplastic ingestion, no.
You are done, Julia.
Thank you so much for your assistance. Go to the lounge and we will be doing that. So.